Okay, so what is a practical problem? Practical problem means it's something you could use on a job or in real life. So we're going to look at some examples, some basic examples, but some good examples nonetheless. Just some review. You don't have to write any of this down. Remember, we have three types of relationships. We have a linear, meaning it's a straight line.
We do have to write it down or no?
You do not. We have quadratic, which looks like a U, or it could be upside down. We have an exponential relationship, which starts out shallow and goes steep.
Again?
So obviously money is a very practical problem. Okay. So you've got a money that you're putting into an account. Now this top is years. Okay, so this is first year, second year, third year, fourth year, fifth year. And then down here, be careful. These numbers are not dollars. It's in thousands of dollars, okay? This 2 represents 2,000. This represents $4,000 in the account after 2 years. 9,000, 15,000, 29,000. This would be an example of what's called a high interest account or a high risk account. When you invest money, you have low risk and high risk. With high risk, you can get money back really quick, but you can also lose all your money. So that's why they call it high risk. This would be more of a high risk account, because in a low risk account, I would never grow this fast. But anyways, just giving you some perspective on that. So there's the amount of money that's in the account after a certain number of time. Again, this is in years. Okay, so 1, 2, 3, 4, 5 years. So we're going to plot this on a scatter plot. And we're going to see what the curve of best fit looks like. Somebody needs to do what?
The top's years?
Top is years, yes. Somebody please read this back to me so I don't have to keep bouncing back and forth. It helps me a lot.
Okay.
Okay, so after 1 year, how much do we have?
2,000.
2,000, exactly. Thank you. 2 years?
4.
3 years?
9.
4 years?
50.
Okay, 4 comma 15. Pretty close. And then 5. All right, so with this one, it's a little tricky. Let me move this out a little bit. 25, so I'm basically just going to have to go as far up as I can because it's kind of off the screen. But can somebody explain to me what the curve of best fit is going to look like for this line?
It's going to be exponentially.
Awesome, thank you. It starts off kind of shallow and then it gets steep, and that is an example of exponential. Okay, on the worksheet I don't think it's going to ask any of those questions, but we do need to sketch the line of best fit for each one. Be with that because this question comes up a lot. So first part, we have to estimate what the y-intercept is. Second part is we need to figure out what that means. It's going to be different for every problem, but you're going to look at the units for the y-axis, and that's going to help you determine what that means. The units are going to change because it's different practical problems. First of all, the reason we draw a curve of best fit is to figure out what the y-intercept is, or at least to guess what it is. Without that curve, it doesn't always give you the y-intercept. So looking at our curve, we can guess that the y-intercept is about maybe 1.5. Okay, it's obviously not going to be 2. It might be 1. We could guess 1, right? It's going to be somewhere between 1 and 2. We'll just put 1 for this one. It's going to make a little bit more sense in terms of this problem. 1. Now what does that represent? Let's go back and look at our units. It says thousands of dollars for the y-axis.
$1,000.
Now what would time be equal to for a y-intercept?
1 year.
0. Yes. 0 would be t, and 1 would be thousands of dollars. So the answer to this question is, when you first put money into the account, the initial investment is $1,000, and I will type that out for you guys. Okay, so every question is going to be different as far as the interpretation of the y-intercept, but that's what it means in this question, and we just have to look at the y axis to determine what it means. So because that's thousands of dollars and time is 0, so that y-intercept means that the independent variable is always 0, so keep that in mind. Let's keep going before we lose our screen again. Second question, around how much money was in the account after 4.5 years? So one of the types of questions you're going to see on the worksheet is they're going to give you the x value. You have to guess what the y value is, and again, that's why you draw the curve of best fit, because that way with an entire curve you can look at this x value and guess what the y value would be. So around how much money was in the account after 4.5 years? Now notice 4.5 was not a number they initially gave us. They gave us 4 and 5. But we can look in between 4 and 5 on the graph and guesstimate.
25,000.
So let's see. Well, let's see. If we go at 4.5, it's actually about right here at 19,000. Looks to me like at 4.5. Oh no, you're right. It is further up.
Probably 24.
Okay, we'll go with 23. I hear what you're saying. So again, it's just a guesstimate, but we will say 23,000. And that's why the word is around, because we don't exactly know how much. But that's why we have a curve of best fit, so we can guess. The third question is the reverse, okay? They're giving you a y value, and they're having you guess what the x value is. So let's read this. After how many years did the account have $20,000 in it? Well, it's going to be a little bit less than that because it was more. Yeah, 4.5 was like 23,000, right? So we need to go a little bit.
4.25.
Okay, 4.25 is a good guess. Let's go back to the graph and see exactly if we can figure out maybe around where 20,000 is. 4.1? Okay, let's see. That's not good. Let's just put another point on here. All right, 20 is right here, right? Something just stopped working. Let's see, 20,000. What'd you say, 4.3? It's really hard to tell. I don't think 4.25, 4.3 is good. Point. You're going to move down to the x-axis, and it's somewhere between 4 and 4.5. And so I think 4.3 is good. So I'm going to put 4.3 for the answer, and that's in years. And you could even turn that into months. Whatever 1/3 of a year is, that's about 4 months, right? So 4 years, 4 months. We're going to stop there.